Hello viewers. Today I'm going to discuss regarding a new software which is FlowMaster. Using this FlowMaster, we can design some drainage system. So at first, open the software. After opening the software, this interface will come and simply we will click here on Create New Project. So after clicking there, you can see that in the Project Explorer, here a project is created and I have to rename the file. For that, I will right click here and click on Save, and I will save here as drainage. So you can see that the file is renamed, and there are some problems which we will solve here. Okay, so let's see the problems. The first problem is a trapezoidal channel carries 2.55 meter cube per second at a depth of 0.52 meters. Means the discharge is given and the depth is given. Also, the channel has a bottom width of 5 meters, a slope of 1%, and 2h is to 1 vertical. In horizontal vertical slope, side slope is given as 2 is to 1. So using this data, I have to calculate the Manning's roughness coefficient. We can manually calculate those, but today I will show it using the software FlowMaster. As it is a trapezoidal channel, so uh, at FlowMaster, I will click on File, New, and Worksheet. Here different kind of open channel worksheet will come like rectangular, triangular, trapezoidal, like this, and I will design as a trapezoidal channel. So I will click here and click on OK. So you can see that the worksheet created, and uh, here it is asking for the solver. What I need to solve here. Here in the question, it is written that the appropriate Manning's roughness coefficient we have to calculate. So solve for roughness. So as I selected here roughness, you can see that the roughness coefficient here it is highlighted. So I cannot edit here. The remaining things I can edit. So the channel slope is given as 1%. So I will input here as 0.01. The normal depth is given as 0.52 meter. Side slope is also given horizontal is to vertical, that is 2. 2 is to 1, so I will click here 2. Also here 2 because the left side slope and right side slope is same. And the bottom width also given. What is the bottom width the channel? That is 5 meter. So I will input that here, and the discharge also given as 2.55 meter cube per second. I have inputted all the data and just I will click here solve. So you can see that the roughness coefficient is already calculated as 0.07. Also here some different things are also calculated like flow area, weighted perimeter, hydraulic radius, top width, critical depth, and so many things. So the first problem is solved. What is the appropriate Manning's roughness coefficient? And now using that Manning roughness coefficient, I have to calculate the depth if the channel carries 5 meter cube per second. In that case, I will solve for the depth. So I will change here. Okay, that particular things will be saved as a worksheet. So I will close here, and same thing I will right click on it and will create a duplicate copy of it. So you can see that the trapezoidal channel 1 is copied here. So I will double click here and the same thing is here. And now I will solve for the normal depth. So you can see that the normal depth is highlighted. So I cannot edit here, and just I will change the discharge, that is 5 meter cube per second, and I will solve here. So you can see that the normal depth is increased as I increase the discharge. So like this, we can solve using FlowMaster. So this one was a trapezoidal channel. Next, I will do for a triangular channel. So I will go to File, New Worksheet, and I will click here a triangular channel and OK. So you can see that the triangular channel is created. OK. So let's see the data what are given. Okay. Use Manning's equation to analyze an existing brick in mortar. Here in the Manning's roughness coefficient is given 0.015. A triangular channel with 3 horizontal is to 1 vertical side slope and 0.05 longitudinal slope. The channel is intended to carry 7 CFS during a storm event. You have seen that the last problem was given in meter cube per second, but here it is given in CFS, means cubic feet per second. So I have to change the unit first in that case. So I'll close here and I will delete this triangular channel at first. And now I will change the unit. So for changing the unit, I will go to Tools, Options, and here I will change the default unit system for new project from SI to US, and I will simply click on Reset Default. So see here that all the units are changed in feet, means FPS unit. So I will click here OK. And now again I will create similarly from File, New Worksheet, and a triangular channel OK. Now you can see that the unit is feet. Let's see the data what are given. Here Manning's coefficient is given, side slope is given, also longitudinal slope is given, channel intended to carry 7 CFS, means the discharge is given, and if the maximum depth in the channel is 6 inch, is the existing design acceptable? Means I have to calculate the depth using those data, and I have to see the depth is more than 6 inch or less than 6 inch. If it is more than 6 inch, then it will be overflow, so that will be not acceptable. And if it is less than 6, then it will be acceptable. So I will solve for depth here, and solve for depth. So I will click here normal depth. The roughness coefficient is given. What is that? 0.015, 0.015. Channel slope is also given. Let's see, that is 0.05, 5% channel longitudinal slope. Left side slope and right side slope are both are same. So that is given as 3:1, 3, and right side slope is also 3. And discharge in CFS is given as 7 CFS. And I will click here on solve. So the normal depth came as 0.52 feet, but 6 inch means 0.5 feet. That is the depth is coming more than 0.5 feet. So the maximum depth is of the channel is 6 inch means 0.5 feet. So it is not acceptable because it is coming more than 6 inch. Now let's see what would happen if the channel were replaced by a concrete. Okay, channel replaced by concrete means the Manning's roughness coefficient will change. In that case, let's see what happens. It is concrete. So I can input here directly 0.01 but also I can select the material from here. I'll click here. Here it is a material library given. I will click on here the material library. Again I will click here. So from here I will click the material as concrete. As I clicked on concrete, you can see that the in coefficient is coming as 0.013 that I have written here. So simply I will click here OK. And again I will click on solve. Now you can see that the normal depth is below 0.5 feet, that is 0.49 feet. So that will be acceptable. So if I change the base means from brick mortar to concrete, then the channel will be acceptable with 6 inch. So this problem is also covered. And now let's do a problem with irregular shape. I will click on File, New Worksheet, and here I will choose the irregular section and OK. So for that I have to edit section. Let's see the problem. Uh, Directly I will go to problem number 4. You can see that it is not a trapezoidal or a triangular. It is an irregular shape. So in that case, I will input this node, this node, this node, and this node. Okay, let's see. This is the y-axis, and here it is x-axis. So this point is at 1 feet above from x-axis and at y-axis. So the point is 0, 1. I will input 0, 1 first point. So I will go to edit section and the section geometry first point will be 0, 1. The next point will be that is at a distance of 20 feet and at a height 0.5 feet. So the point will be 20.5, 20 and 0.5. So let's input the second point as 20, uh, 20 and 0.5, and the third point that is 20 plus 5 means 25 feet and it is on x-axis, so 25 0, so it is 25 0. And the last point which is at a distance 20 plus 25 plus 10, 35 feet in x direction and 1 feet above in y direction, so that will be 35 1. Let's input 35 1. So you can see that the channel what is given there, the shape already came, and now I have to input the roughness. For that I will click here on the drop down option and simply click on it, and the roughness I will input. What is the roughness given? The Manning's N value is 0.018. So I will write here 0.018 and I will click on OK. And the channel slope that I have to input. Acha. At first, what is the question I have to see? The capacity of the channel. So that is okay. The solve for discharge, and I have to input the elevation here and the channel slope. So the elevation acceptable depth is 0.75 feet and the slope is given 2%. Slope is 2% and elevation is 0.75 feet. And I will click on generate. So you can see that the discharge is coming as 33.63 fps cubic feet per second. So by this way we can design any kind of uh, discharge here of this channel like rectangular channel, triangular, trapezoidal or any kind of irregular channel. So we can see the channel cross section. Simply I will click on the section, double click, and here I will click on the cross section and OK. So you can see that this is my channel. This is the depth of water at 0.75 feet and that is 1 feet. So today up to this. In the next video, I will discuss about more on this topic. There will be some complicated problems will come. So for today, it is done.